week, we talked about adding and subtracting fractions that had the same denominator. This week, we're going to talk about, or excuse me, today, we're going to talk about fractions that do not have the same number in the denominator. They're different or they're unlike denominators. So when we add two fractions together, we want to make sure that we check out the denominator, okay? Because if the denominator is the same, we do one process. If the denominators are different or unlike, we have to do another process or different steps. Okay, so let's look at those steps. And this is just a review from last year. It's just that we're going to be adding positive and negative fractions. Okay, now we're on page one in your packet. Okay, so let's talk about the steps to solving these problems. Okay, as with any fraction problem, the first thing you want to do is you want to convert any mixed numbers to improper fractions. And we got some practice doing that today in our warm-up. Okay, whenever you have any kind of a fraction in the problem, you need to make all the numbers look like a fraction. Okay, and I talked briefly about the circle method for you today. Okay, and we did that in the warm-up, and we'll talk about it again here in a second. Okay, so you want to use the circle method to convert mixed numbers to improper fractions. And you need to do that first because all of your numbers need to look like fractions. Then once all of your numbers look like fractions, you want to ask yourself, are the denominators the same number or are they a different number? If they're the same number, we're going to follow the steps that we took last week. And if they're a different number, we're going to follow a different set of steps, which we're going to learn to do today. Okay, now just review. Because remember, if the denominator is the same, that's easy. That's what we want to see because it makes it easier on us. So if the denominator is the same, we're going to perform the math operation on the numerators only. And so you want to look at just the numerators when the denominator is the same number. We just look at the numerators and we ask, are we adding or are we subtracting the numerators? If we're adding, now remember, we're adding, subtracting positive and negative numbers. So what do we want to use when we're adding? What process or what memory device? The T-chart. So when we are adding positive and negative numbers, we want to use the T-chart. When we're subtracting, what do we want to use? SAO. Okay, and that's what we did last week. And that's what this process is what we use to calculate the new value of the numerator. And then at the very end, the denominator remains the same. Once we get the denominator the same, it never changes after that. So if we start off with the same denominator, it stays the same in the final answer. Okay, that's what we did last week, and that was what we said was easy. Now, what's not so easy is what do we do if the denominator is not the same? If the denominators in our fractions are different. Okay, so what we have to do when the denominators are not the same, we have to find a common denominator and convert each fraction into its equivalent fraction so that the denominators become the same number. Okay? Once the denominator is the same number, then that's easy. Then we come back to this process. Once the denominator is the same, we only have to do the math operation on the numerators only. So remember, our goal is to get those denominators to look at the same. They need to be the same number. Then we're performing the math operation on the numerators only. So if I'm adding, you want to ask yourself, if I'm adding, what can I use to help me solve to calculate the new numerator? If I'm adding. If I have something like this, if I have 3 plus negative 8 over 5, and I'm only looking at the math operation in the numerator, how would I solve this problem up top? If I'm adding, what device do I use? The T-chart, okay? If I'm subtracting, what do I use? No. If I'm subtracting, what strategy? Correct. SAO. Next year, you get to use calculators, okay? Okay. Because you still have to learn how to do it in 7th grade because you're not in 8th grade. Then once you get the denominators the same and you calculate the new numerator value, you're going to leave the denominator the same. Okay, once you get that denominator equal in all of the fractions, once it becomes the same number, it stays the same number. It does not change. Okay. Then because our answers are always in fraction form, we have to check to make sure whether we need to simplify it or not. So we may have to convert it. If I have an improper fraction, I need to convert that to a mixed number to get the proper form of the answer, okay? Okay, so, yeah. Okay, so let's look at the next page. So go to page 2. We're actually going to go through a problem together so that you can get practice using the process. Okay, what do you think the first thing I'm going to ask you to write is? What should we always do? Our T-chart, okay? So what goes here? Same. What goes here? Different. Abbreviate. What goes here? Add. What goes here? Subtract. And then what goes here? Keep. And what goes here? Oh, I was right, opposite. Goodness, what am I doing? I'm totally off there, aren't I? Larger. Okay. Now, what about SAO? S stands for same. So we keep the first number the same. A stands for add. We change subtract to add. And then we change the last number to its what? To its opposite. Very good. Okay, because we have to know this. When we calculate the new numerator, we're actually doing an addition or subtraction problem. So we need to know this. Okay, so let's look at the first problem. It says 3/8 minus 1.5. So remember, step 1, convert mixed numbers to improper fractions. So I use the circle method. In Google Classroom, I have a link. If you want to go out and look at it, there's a link out there in your Google Classroom that you can view to see this method. So remember, from our warm-up, we want to draw our circle with our arrows, right? And we're going to come all the way back around to the denominator. What math operation goes down below here? Multiply. And what goes up here? Add. So we're going to say 2 times 1 equals 2 plus 1 equals 3. And then I come all the way back down and I keep the same numerator. So that becomes 3/2. Okay, so we converted the mixed number to an improper fraction. That's easy to remember, isn't it? Okay, so we're going to rewrite the problem now. We're going to say 3/8 minus 3/2 because we converted it. Okay, so now you need to ask yourself, are the denominators the same number or are they a different number? So when you look at this, they're different. Okay, now we have to convert these to equivalent fractions. Okay, one of the easiest ways to do this is to look at your smaller number and see if it goes into the other number. So in other words, can 8 be divided by 2? Sure I can. If I get a whole number, 8 divided by 2 is 4, right? So that means 8 will be my common denominator. So 3/8 stays the same. And then we're going to say this over 8. Well, what number times 2 gives me 8? 4. So 2 times 4 gives me 8. But remember, you guys, what I do to the bottom, I got to do to the top. So that means 3 times 4 is the new numerator in this equivalent fraction, which is 12. Okay? So 2 times 4 gives me 8. So now the numerators are the same. And then what I do to the bottom, excuse me, the denominators are the same. And then what I do to the bottom, I got to do to the top. Okay? So we just found what's called the lowest common denominator. Again, I have a link on the Google website if you want to learn how to do this. There's a link on the Google Classroom for you to go and check out. Okay? Now, the denominator is the same. So now what we have to do is work with the numerators only. So I'm going to rewrite my problem, and I'm going to put my numerators and the math operation. So I'm simply going to say 3 minus 12. Okay, and I'm going to put that up top. 3 minus 12. All over 8. Okay, now remember, in problems like this, my denominator is going to stay the same. I made it 8, so that's not going to change. So the only thing I have to look at right now is how to calculate this value for the numerator. Okay, and that is where you have to ask yourself, am I adding or am I subtracting the numerators? Now in this case, what are we doing? Adding or subtracting? We're subtracting, so what are we going to do? What strategy? We're going to use SAO. Okay, so I'm going to write my S above the 3, my A above the minus, and my O above the 12. And now I'm going to keep the first number the same, that's 3. Then this becomes add, and then this changes to its opposite. And I always keep the denominator the same. Okay, remember, this is part of a fraction. Now, what are we doing here, you guys? What's happening in the numerator? Am I adding or subtracting? Now I'm adding, and I have to use what? The t-chart. So the t-chart tells me what if the signs are different. Because the signs are different. This is positive, this is negative. So we're going to subtract. Just forget the signs. We're just going to take just the numbers themselves, the numerals. 12 minus 3 is 9. But is it positive or negative? It's negative because 12 is larger, so it has to be negative 9 over 8. Now, is my numerator larger than my denominator? Forget the sign. That's a very good point, and you're correct, but let's forget about the sign for a second. Is 9 bigger than 8? Okay, so we're going to have to do a little division here. So we're going to say 8 goes into 9 how many times? 1 time. We take one group of 8 away. That leaves me with 1. So then remember, the remainder becomes this over this. So it becomes 1 over 8. But I can't forget my negative sign because my answer is negative. So the answer will be negative 1 and 1 over 8. Okay? And we simplified our answer. Okay? So all you're doing is you're bringing all of your steps together in one problem. Okay? So what I want you to do is work on the next 4 problems for the rest of the period. You've got 18 minutes, 17 minutes. And what I want you to do first, see this right here? You need to follow all your instructions. What does this say? Write down the t-chart. I want to see you write down the t-chart. Write the SAO strategy. In other words, S means what? A means what? O means what? Okay? So follow the instructions.